I'm presenting today more as a professor at my university, Texas A&M University in Texas, and I want to give an overview of a project that I've been developing with Dr. Christine Picard at Indiana Purdue University and Dr. Heather Jordan at Mississippi State University. So just a little overview. Obviously, we all recognize that the global value of insects as food and feed is growing at a very substantial clip. And that's not just in terms of economic value, it's also in terms of the number of companies that are involved in the industry, as well as the number of research institutions that are involved in programs to help increase the efficiency and optimize the process. But when you look at the system, you really want to think about where we are today versus where we were just 3 years ago and where we hope to be in the next 5 to 10 years. When we look at the insect models that are traditionally being used in the insects as food and feed industry, we recognize black soldier fly, obviously, mealworm, and cricket as the three primary insects that are being mass produced. The products that are coming out are fairly limited right now, but based on presentations, we're starting to see more individuals investigate opportunities there with those products being produced, being the insect-based protein, the fats associated with it, and the compost that's generated through the process. But what we're seeing, and we see it today even with the presentations, is that there's a lot of markets that are being opened up to the insects as feed industry. That being obviously pet food, which was valued at over $25 billion in 2016 and is expected to be over $30 billion by 2022. When we think about human consumption in 2017, we're looking at approximately $55 million industry, but that's expected to increase to over $270 million in the next 4 years. So we're seeing this quadrupling of value of the insects as food industry. Two markets that we're all very well aware of. If we think about poultry, that market is massive, with it being valued at over $3 billion. And then if we think about the aquaculture industry, which has a market value of about $500 billion if you think about every aspect of it. Now, the idea of going from point A, where we are today, to point B, if you want to call it point B, of providing for these industries is a monumental task. It's like Evel Knievel jumping over the Grand Canyon on a motorcycle. How are we going to do that? And I think that's what we see a lot of presentations on here today, and we've seen it in the past at IFW and other conferences, is how can we increase the efficiency, increase the production to meet these demands? Well, right now, if you think about it, even with the presentations that we see today, is that research and application typically occurs in silos. You have company A working with University A, or company B working with University B, but we don't see much cross-pollination in general. Now, obviously, there are universities that collaborate. I've worked with some of you that are even present today, and that's there. But are there ways that we can actually work together more efficiently and thus advance the industry much more quickly? And that gets at this idea that usually these silos are located throughout the world, so communication can be lacking at times. And then if you think about platforms of communication, obviously IPIF is out there, AFIA, NACEA, the Australian Association. So we have these platforms to engage regulatory bodies on getting insects approved or their byproducts approved for use as feed or food ingredients. So those platforms operate. Now, the level of communication across those platforms can be somewhat fragmented today. With regards to platforms, we also have other opportunities to present results from research. We think about meetings such as today, what we're doing, or if you think about Insects Feed the World, or if we think about the Entomological Society of America or Insects that occurs in Germany. So there's research bodies that allow for data to be transferred out to the public or to industry. But again, these are fragmented opportunities. You got research isolated in silos. You have organizations communicating with regulatory bodies that are isolated. And then you have these individual conferences that occur once a year and allow for some results to be presented. Obviously not all, because Some are protected under confidentiality agreements. So what are the issues that we see? Well, clearly funding is an issue. How do we fund the research that we want to see done to help industry advance? And this can be really challenging for several different reasons. One being the industry doesn't want to share results. B, allocating funding to do research can be quite expensive, especially when you consider universities charge fees on top of the research to be done. And then what you end up with is this research being focused. And how startup companies or advanced companies allocate funding for research can be challenging as well. So is there ways to increase synergy? Well, that's a big question to be answered through this topic we're going to discuss in a few minutes. Another aspect of what the issues are is also looking at product diversification, which I'm going to mention a little bit on. Market stabilization. This gets at the idea of poultry's wanting 2.1 million tons of protein per year. How do you supply it? And also the cross-pollination ideas. How do we get researchers and industry working closely together? So if we think about some of the issues that we face, we have to also think about other competitors out there in the market, specifically commodity groups. I really want to caution everybody on this idea of saying we're going to replace soy or we're going to replace maize, because what you're looking at is these large commodity groups that already exist and have they're quite stable and they're quite well established, not just in terms of use, but also politically. We need to be thinking about how we're going to work with those groups and synergize rather than compete with those groups. And that's something I would like for everyone to think about. So I talk about the funding issue, the synergy and corporate issues, but also developing global standards. How are we going to produce these products and what are the minimal standards for them to be used around the world? And further is how do we optimize that process and more importantly, diversify, not just in terms of the products we produce, but also the insect models that we're going to focus on. I mean, if you think about the number of insects that are consumed globally, we're talking about 3 species here today with mealworm, black soldier fly, and cricket. In terms of product diversification, can it be done? Of course it can be done. If you think about the number of products that are produced from a single pig carcass or from a single cow, the same can be done with an insect. And those byproducts can be not only the protein and the fat, but it could also be, as we discussed, it can be the chitin, but it also can be essential amino acids. Black soldier flies are very high in methionine. Maybe it's a way to produce methionine. And this could be an example where it actually conflicts with the old adage of the sum of the parts equals the whole. This could be a case where the sum of the parts is greater than the whole, which gets at some old school economic theory that holds true today, even in the stock market. But the idea is sum of the parts is greater than the whole, and I think we can do that. So through the center, which I'm going to talk about, is there are opportunities for the center to actually synergize beyond these 3 institutions that I mentioned initially: Mississippi State, IUPUI, and Texas A&M. When I lay out the framework of what the center looks like and how it's going to operate and who's funding it, there are opportunities through its framework to partner around the world. And I have had researchers send their students to work in my lab, and through the center, there may be opportunities to fund those students to come work in my lab or work in another lab, which means they can get expertise in genetics, microbiology, life history traits, feed trials, all of those, and probably much more. So what is an NSF Center? So this is a program through the National Science Foundation. It's called the IUCRC. It's a collaborative effort between industry and universities. It's trying to find a way to translate research to industry faster and more efficiently financially. As I mentioned, there's 3 sites that are being proposed through the center: IUPUI, which focuses on genetics; Mississippi State, which focuses on microbiology and quality assurance; and Texas A&M, which focuses on optimization of processes and feed trials. Now, the way it works is that the umbrella of the center will be the National Science Foundation. And we submitted the grant September 8th. We had already gone through a planning grant last year. So we had a planning meeting. We had 20 industry partners from around the world show up, and we discuss how the center would operate. Now, if we get selected for funding, the National Science Foundation is going to kick in $750,000 per site. So I listed 3 sites. Each will get $750,000. That covers all administration of the center. Now, where does the funding come from where does the funding originate to do the research? That comes from you, the industry partners. To serve on the industry advisory board, it takes a 1-year commitment of $25,000 to $50,000. Now, what does that mean? That threshold is put in place so that the big companies cannot saturate the market or saturate the center and control the voting. Because in the end, the industry advisory board will vote on what projects get supported. And those projects are presented through those 3 entities that I mentioned. So they get to decide what projects get funded. And the beauty of it is the National Science Foundation says that the overhead that the university charges is limited to 10%. So the majority of the funding goes to support the projects. And these projects are 1-year projects. So we're talking about a quick turnaround on these projects to generate the data for the center. So an overview is each company would contribute $25,000 to $50,000. What does that mean? Well, you get a project that you get to vote on across the board. Now, here's the beauty of it for industry. If you contribute to a project for $25,000, you have access to all of the data across the center. And to put it in perspective, when we submitted the grant, we had $950,000 of financial support offered by industry for 1 year. So if you contribute $25,000, you have access to all of the data. The results are quick, within a year. Here's another perk. National Science Foundation says universities cannot charge royalties to any intellectual property developed. So if intellectual property is developed and a company licenses it, they cannot charge royalties on that. Another benefit that comes through the center is obviously we will be training people that could eventually come work for your companies because they're going to be working on projects. They're going to be working with you because you're help funding the project. So we could actually train those individuals that could eventually be your future employees. Also, with that in mind, going back to this idea of cross-pollination around the world, is that if you're located, let's say in South Africa, or if you're in the UK, or the Netherlands, or in Australia or somewhere, and you're working with a university, you can have a student from a local university come work in our lab and be supported by the money that you put into the center, and they could come work with us and get trained by us and then come back and work in your company. And again, another big perk of the center is that you get to make the decisions, not us as researchers. You tell us what you want to fund. And the beauty is, even if you write a letter of support and provide funding, and you come into it supporting a project, when you hear the projects and you meet with the industry advisory board group, you can change your support to another project. You can even have projects come together. So you get to actually engage industry across the board, and you get to work with other industry groups on developing bigger projects. So that's a beautiful part of the center as well. And this goes back also to this idea that how do we engage you? Well, the center meets twice a year. That means the industry advisory board is meeting twice a year. Secondly, that means information is being transferred quickly. We also will hire someone to be the center liaison, which means they're independent of the institutions involved, and they serve as the engagement of the industry as well as engaging those platforms we discussed, such as IPIF, NOCIA, or other groups that are engaging the regulatory bodies. So this is an opportunity to synergize. Now, I wish I could share this last slide with you, because what I would like to show you is all the companies that have written letters of support for the center, including, I mean, the list is long. It's over 25 companies. And as I said, for the first year, they've written letters in total value of $950,000 that would be allocated to research. This is a great opportunity. If we get this grant and we establish it, there are opportunities for the center to diversify and grow and add more sites in, and each site would get that NSF grant. So there's great opportunities there. Uh, this is a beautiful opportunity, and I appreciate the time to come here and talk to you about it today. I'm sorry the slides didn't work. If you
No,
have
man.
any questions, you're more than welcome to
Just
contact me, and I'll be glad to answer them. Thank you.